So today's lesson is lesson 1.7. We are going to talk about three-dimensional figures. So the first thing I want to do is go through some definitions with you, and then I'm going to talk about the figures that I've drawn. So a polyhedron is a solid with all flat surfaces that are enclosed in a single region or space. Each flat surface or face, so the flat surfaces are called faces, and they're polygons. The line segments where the faces intersect are called edges, and the points where three or more edges intersect is called a vertex. So I've drawn a rectangular prism for you. So this rectangular prism is a polyhedron. It has flat surfaces that are all enclosing a single region or space. Each flat surface is a polygon. This is a rectangle, which is a polygon. It's a flat surface. This is a rectangle, which is a polygon. And then obviously the back and the bottom side that you don't see. When I talk about, so all of these are faces. All of these flat surfaces are faces. An edge is this. It's a line segment. So an edge is actually a line segment where two of the faces meet, right? So you know that makes sense. And then where three faces meet, so here I have one face, two faces, three faces. Where three faces meet is a vertex. Okay? So all three edges meet at one point called a vertex. So that makes sense. Polyhedron can be prisms or pyramids. In a prism, think of a prism as like a Kleenex box. There are two parallel congruent faces called bases. So if I were to go back up to this drawing here, this would be a base. And what you don't see on the bottom is also a base, right? It's like a box. So the bases are congruent to each other. In a pyramid, so I tried to draw a pyramid for you, you only have one base. So this is the base right here of my pyramid. And then the faces are actually triangles. And to make a pyramid, your faces, the number of triangle faces, you have to have at least 3 triangle faces. And that makes sense because let's say that my pyramid had a triangular base, then it would require 3 faces to go around the side. I know that's not a great drawing, but you get the idea. So we also, when we're talking about solids, this is 3-dimensional figures. So there are some solids that are not polyhedron, like cylinders, cones, and spheres. They're still solids. They're just not polyhedron because they do not have flat faces. Their surfaces are curved. So that's why they are not polyhedron, okay? All right, so let's talk about naming them. So I have a polyhedron here, and I have a polyhedron here. The directions say to determine if the figure is a polyhedron. Yes, these are both polyhedrons because all of the faces are flat. They are not curved faces. They are all flat, okay? So if they are polyhedron, which they are, we have to name them. So the first one is a base. Well, the first one is called hexagonal prism, but it's because of the base. The base has 6 sides, which means it's a hexagon. So this is a hexagonal prism. It is a prism because it has two congruent bases. Hexagonal prism, okay? The second image that I want you to look at is this right here. And this is a rectangular prism. Also a prism, has congruent bases, but this is a rectangular prism. Notice that the faces of the hexagonal prism and of the rectangular prism, the faces, not the bases, but the faces are all rectangles. Okay? So we're asked to name the bases, the faces, the edges, and the vertices. Well, the base of the hexagonal prism, they're actually planes, but we're going to just say hexagon, KLMNOP, and hexagon, EFGHIJ. The base of the rectangular prism, well, these are rectangles, so it's rectangle A, B, C, D, and rectangle E, F, G, H. The edges are going to be line segments, and the vertices are actually going to be points. These are types of platonic solids. So this is an equilateral, a tetrahedron, which has 4 equilateral triangles, a cube. I don't have any specific questions about the names of them, but it's good to know them. But again, you don't have any questions that are specifically about an icosahedron or a dodecahedron. All right, so I took those images from the last example, and I just brought them over here because I want to make sure that you understand how to name the edges. So this is the hexagonal prism, right? We said it's a hexagonal prism. So when we talk about naming the edges, you remember that the edges are just the straight lines. These are actually line segments. So for example, I have segment KE, segment LF, segment MG, segment NH, segment OI, segment PJ. But I also have segment ON, segment KP, segment KL, segment LM, segment MN, and segment PO, as well as segment EF and segment FG and segment GH and segment HI and segment IJ and segment EJ. So edges are line segments. So I want you to remember that because I want you to make sure that you name them right. So they are line segments. So that means that they have to have a segment bar over the top. Vertices are points, so you can just name them for the letter that they are. All right, now let's talk about surface area and volume. We're dealing with 3-dimensional shapes. I have 2 polyhedron and then 3 non-polyhedron, but I really want to focus on the formulas. So the surface area of a prism, so the surface area, I'll write it down here so you can see, of a prism, this formula works for all prisms, is the perimeter of the base. That capital P stands for perimeter of the base, times the height of the prism, plus 2 times capital B, which is the area of the base. And then the volume of a prism is just the area of the base. Oops, I didn't spell that right. Area of the base times the height. So every year that we do this lesson, and this is just an introductory lesson, like you'll actually get more exposure with solids later on, but every time we have this, students are like, do I need to memorize the formulas? So this is this is an 8th grade standard, 8th grade standard, 7th grade standard, 8th grade standard, and I think that's a 6th grade standard. So you're in a 10th grade math. So you have to know these. You have to know these formulas. So when we take a chapter test, which really is going to be on Monday, when we take our chapter test, I will not give you the formulas for surface area or volume of these shapes. I expect that you know them. Okay, so let's do